Welcome to the DIY Honda Garage channel. The DTC P16BB indicates a problem with the alternator's B-terminal circuit experiencing low voltage. In Honda vehicles, including the Accord from 2012 to 2017, the alternator plays a crucial role in charging the battery and powering electrical systems once the engine is running. Specifically, the B-terminal is responsible for delivering battery voltage to the alternator. When this circuit is compromised or experiences low voltage, it can lead to underperformance of electrical components, ultimately impacting the vehicle's functionality. Symptoms of this DTC could include dimming lights or difficulty starting the engine. Thus, performing a thorough diagnostic assessment is essential to determine the exact cause and implement an effective repair strategy. In conclusion, tackling DTC P16BB necessitates a systematic approach to accurately diagnose and repair the issue at hand. Key steps in this process include verifying and checking the alternator and its connections, investigating wiring integrity, and conducting thorough final repair verifications. It's critical to recognize that the integrity of electrical connections directly impacts the vehicle's overall performance and reliability. Regular maintenance, including inspections of the alternator, battery, and associated connections, is essential to mitigate the risk of experiencing such low voltage issues in the future. By following the detailed troubleshooting steps and maintaining habitual checks, drivers can ensure that their Honda Accord remains in optimal working condition, free from DTC-related complications. The DTC P16BB refers to a low-voltage condition specifically in the alternator's B-terminal circuit. The affected component is the alternator, which is typically located on the engine block, driving power to charge the vehicle's battery and operate various electrical systems. The B-terminal connects directly to the underhood fuse/relay box, which houses fuses and relays for various electrical components. A malfunction in either the alternator or the connections to the fuse/relay box can lead to low-voltage faults being registered. When these components are not functioning properly, it can result in performance issues, such as reduced battery charging capability or failure to power essential electrical systems, which could create starting problems and operational inefficiencies. There are several possible causes for the DTC P16BB, primarily involving the electrical connections. First, poor connections or loose terminals at either the alternator itself or the underhood fuse relay box can lead to insufficient voltage supply, triggering this diagnostic trouble code. Second, there may be an open circuit in the wiring between the alternator and the fuse relay box, cutting off necessary power transmission. Lastly, if the alternator itself is malfunctioning and unable to produce adequate voltage, this would also result in a P16BB code. Each potential cause needs to be thoroughly inspected to ensure accurate diagnosis and effective repairs. The symptoms associated with DTC P16BB are often linked to electrical performance issues. One of the most evident symptoms may include difficulties in starting the engine, as the alternator's inability to maintain adequate voltage can prevent the battery from delivering sufficient power. Additionally, drivers may notice dimming or flickering of interior and exterior lights, indicating insufficient power supply. Other manifestations can include erratic performance of electrical systems, such as inconsistent operation of the air conditioning, radio, or dashboard displays. Recognizing these symptoms is key to diagnosing the underlying issue associated with the P16BB code and ensuring a comprehensive repair. The first step in troubleshooting DTC P16BB involves verifying the problem conditions. Begin by turning the ignition switch to the on position, or pressing the engine start-stop button to enter the on mode. After ensuring the ignition is on, it's essential to clear any existing diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. Following the clearing process, start the engine to create a controlled environment for the assessment. Specific conditions should then be created. Turn on the AC, set the temperature control to maximum cool, and increase the blower fan to maximum speed. Also, turn the headlights on high beam and activate the rear window defogger. Finally, hold the engine speed at 2,000 RPM without load, allowing the vehicle to operate under these conditions for 1 minute before checking for any pending or confirmed DTCs again. This is a crucial step to ensure that any intermittent issues are captured. The second troubleshooting step focuses on checking the alternator's +B terminal connections along with those at the underhood fuse/relay box. It's vital to check for any poor connections or loose terminals because such issues can lead to low voltage signals being transmitted. If the connections and terminals are found to be in satisfactory condition, you can confidently proceed to the next step. Conversely, if any problems are identified during this inspection, they must be repaired immediately. This inspection might involve tightening loose terminals, cleaning corroded connections, or replacing damaged wires. Ensuring strong electrical connections is essential for the proper functioning of electrical components and to avoid experiencing the P16BB code again. Continuing to the third step, it is crucial to check the wiring between the alternator and the underhood fuse relay box for any signs of an open circuit or damage. Inspecting the engine wiring harness specifically for breaks or disconnections is necessary to ensure continuity in the voltage supply line. If the wiring harness is confirmed to be intact, the next logical step would involve replacing the alternator. However, if any damages or breaks are discovered in the wiring, these must be repaired before replacing the alternator. Proper diagnostics at this stage are essential to ensure that any low-voltage issue is effective and successfully resolved. Addressing wiring issues is a fundamental component of restoring the proper function of the electrical system and negating DTC P16BB. After completing the necessary repairs, it's critical to perform a final verification to ensure that the issue has been resolved. Begin by setting the ignition switch to the on position again and use the HDS to reset the powertrain control module, PCM. Following this reset, it's essential to perform the PCM idle learn procedure to update the engine management settings. Then, start the engine while ensuring that the same conditions from the initial diagnostic check are met. AC on, temperature control in maximum cool, blower fan at maximum speed, headlights on high beam, and the rear window defogger activated. Hold the engine speed at 2,000 RPM for 1 minute without load, and then check for any pending or confirmed DTCs once more. If DTC P16BB appears again after these steps, further investigation into other components related to the electrical system may be necessary. Preventive maintenance plays a vital role in avoiding issues related to DTC P16BB. Regularly inspecting electrical connections at both the alternator and the underhood fuse relay box can help prevent low voltage scenarios. Ensuring that connectors are clean, tight, and corrosion-free is essential for maintaining optimal electrical performance. Additionally, routinely checking the battery's condition helps ascertain that it can effectively hold and deliver charge. Monitoring alternator performance should involve checking the voltage output during normal operations. Keeping an eye on these components and their condition will significantly reduce the risk of encountering low voltage issues and help preserve the overall reliability of the vehicle's electrical system. Please like and subscribe to the channel. See you next time.